this presentation, setting up the MBD Foundation to maximize returns on technology investments. That's a long way of saying this is just MOOG's MBD journey, the beginning of it. So I'm Matt Payton. I'm a CAC systems engineer for MOOG out of the Blacksburg site. And I've got a couple friends up here who've been helping us. I'll let them introduce themselves.
All right, my name is Dan Fury with Action Engineering. We're a niche MBD specialty consulting firm helping organizations implement model-based definition for consumption in a model-based enterprise.
And I'm Rudy Lozano. I'm Rudy Lozano, one of the account managers at Capvidia, and we focus on reuse of PMI for downstream consumption, mainly machine consumption. Oh, you don't need it. Yeah.
So just a little bit about MOOG. MOOG is a large aerospace company. They have an industrial group, aircraft group, space and defense group. I happen to work for the space and defense group out of Blacksburg. Here's another overview just to give you an idea. We are a worldwide company. We do quite a bit of sales. We're involved in several markets here, as you can see. But I work out of Blacksburg, so I'm just going to talk about most of Blacksburg here. You can see the little location dot there, Blacksburg. It's Blacksburg, Virginia. If there's any Hokies in here, go Hokies. It's where Virginia Tech is. It's nestled in the Appalachian Mountains. You know, the Appalachian Trail, the New River, go right through there. And we have around 800 employees in the Virginia area. We were acquired by MOOG. It says 2005 and 2007. What does that mean? Well, that's we had two companies in Blacksburg. They started out as one company. They had a disagreement sometime in the 1960s, and they were reacquired by MOOG and brought back together. So we're one big happy family again. Our primary business is electromechanical components. These are slip rings, twist caps, motors. We also have a circuit board design house, so we make our own circuit boards. They do, take orders and stuff and do stuff for other people, but it's great to have our own circuit board in-house. Now, this is the model-based roadmap for MOOG overall. This is our vision. You start out model-centric, you go MBD, you go MB little e, and then you go MB big E. And I think the little e, I forgot what the little e meant, but the big E is model-based enterprise. Engineering, thank you. And you can see the little pin there. We are 2 years into this journey. And where did we start? So in Blacksburg, we had been using our 3D models, we've been using them like everyone to create drawings, right? Just use your 3D models, make a drawing. But we slowly began implementing more and more intelligent modeling practices because we wanted to remove manual entry into our models. We wanted we didn't want to author things on our drawings so much. We wanted them to come from our models. So we started doing things like the whole command. We started using our feature patterns. Huge one, no overridden drawing dimensions. Once you can tackle that, you're halfway there, really. Properly naming of our items. We actually came from ideas before we went into NX. Ideas was a little more lax about the item naming and stuff, so we had to overcome that early on to get everything aligned with our ERP system. We started using assembly cuts, trying to encourage people to not use dummy models. People used to make dummy models. So assembly cuts were actually capturing our manufacturing process. We would assemble things, mold it, and then come back and machine it. So we started modeling things the way we were actually manufacturing. And rumblings of model-based. At the end of 2019, we had this cross-departmental event that we held, and we really wanted to speak to management, speak to a lot of our users and stuff, and just show them some of the capabilities that we had. We had all these tools, and we weren't utilizing them to their full potential. So we had this event. We started talking about how we could use our 3D models to improve our processes. The immediate payoff from that event is we opened up our CMN inspection groups. We gave them access to Team Center. They were able to go in there, grab step files, and huge time savings for them. They could import those into the Calypso software, PC Demas, we use both of those, and save them quite a bit of time. We also started using our JT files. We have JT files. We had been creating them. We're like, what do we do with them? Well, people started asking us, we get younger people started coming in and, hey, do you have a model for this? Can I have a model for this? Can I have a model for this? So we started taking our JT files and really using those. We created an internal website where we were loading these JT files up. And those are also a big hit. We used for work instructions, building, planning. But we were storing those on a site. It wasn't really part of the PLM system. We also began creating these basic assembly videos. We would take our models and make little videos of how things would assemble. Originally, we were doing that for our model shop, and what we found is, they were a huge hit in our design reviews. All our salespeople wanted these assembly models, which became its own problem, by the way, because of time. But it was eye-opening. It was eye-opening the power that you could get out of these models. We began training our machine shop how to use Team Center and NX so they could go in, grab their own models, basically removing obstacles from the machine shop to the 3D models. We wanted to give them access to that stuff. So we're making a lot of momentum. Then 2020 happened, right? Everybody knows what happened then. The pandemic years. So really, I feel like the pandemic forced our company's hand in many ways towards digital solutions here because we had to have remote work. We were still doing manual sign-off on our drawings at this time. So something we've been trying to get going for years, all of a sudden, you have to get this done. We developed one very quickly. Great, it worked great. Everybody's fears about how we're gonna sign our drawings no longer existed. People are seeing these tools actually work. Value is clear. Around the same time, MOOG at large, the larger company, they were developing a PLM system. They were replacing their enterprise system, a PLM system. They were thinking about this stuff too. The puzzle pieces were falling into place, and what happened is we started an MBD pilot project in Blacksburg because our experimentation with this stuff was starting to line up with MOOG's overall goals for this digital transformation. So that started in early 2022. We called that Project Space Cookie. I know it's kind of an enigmatic name there. So the part you see there that looks kind of like a cookie, that was one of the original parts that we were evaluating, and the name Space Cookie stuck. So that is the infamous Space Cookie that you're seeing right there. On the right, what you can see is the part that we're actually working on right now. We're doing a single component for our MBD pilot project. So in order to do this, we sought out some guidance. Sought out guidance from Action Engineering for MBD training. Tell us what this MBD is all about. We kind of think we know, but do we really? So he gave us, Action Engineering gave us guidance, they gave us knowledge sharing. Really importantly, they are up to date on all their standards and stuff because there's a lot of emerging standards that are happening right now. We also learned about something called a QIF file. And you probably went to other demonstrations on this, but huge thing, this QIF file. Benefits are obvious for our quality inspection departments. We started utilizing Capvidia software, which creates these bill of characteristics that you can derive straight from your 3D models. And this was instantly a hit with our CMM programs. We haven't even got into the full breadth of this yet. The CMM program is like, yes, we want this. So where are we now? Well, Project Space Cookie, it's been running for the last 2 years. We're gathering tons and tons of insights, information from this. You see these phases here, phase 1, phase 2. We're in the middle of phase 2 right now, and we're going to start introducing some change scenarios into this. Some interesting insights that we found, not on the slides here, but I was down in the machine shop. We had them run that frame that you saw, and a lot of complaints. We need a drawing. We don't know how to get our dimension and stuff. So they actually showed them how to create a process model and things like that. But when I was down here talking to it, another machinist came up, and he was complaining about his drawing. He's like, man, I wish I had a model so I could get this dimension. So it's a give and take. It's a give and take. People are seeing the advantages of a model. They're still going to complain about it though. So since then, we have launched several other MBD pilot projects across MOOG because what we're seeing is there's customer requirements that are coming in that are calling for MBD. We're also seeing that a lot of managers and different employees are finding out about MBD from different places and they're interested. And some people will go off and do their own thing and we'll find about it and we'll go help them out. So the biggest thing that we're getting ready to do is set up a complete MBD dev environment, a playground, that's so that we can develop our business practices better. We've been kind of doing everything in our existing system. We're at the point now where we really need to change some of the processes, change some of the workflows, change some of the item types and things like that. So that's the exciting news. We've got that ready to go. We just need to install it really. And with that, I think I'll turn it over to...
All right, thanks, Matt. So before we go into a little more detail of how we started laying an MBD foundation for MOOG, if you mention MBD or MBE to 3 organizations with 3 similar product lines, similar core competencies, you could get 9, 10, 15 different responses for what MBD, MBE is and how they want to implement it. So MBD is complex. Part of the complexity is that we focus on the digital or the machine consumption of model-based definition, but there still is a human factor, where as humans, carbon-based life forms, we need to be able to look at the data and interpret it the same level or better than we did previously with 2D product definition. So I'm going to put Dave on the spot here. I didn't give him any warning on this. Dave, I've got an enhancement request that I submitted a while ago. I've not heard any update on it, and I'm sure the crowd would be pleased to know. We're looking for a new functionality when it comes to the PMI tab in NX. The tools are amazing. You guys have done an incredible job, but we're looking for that easy button. And until we get that easy button, and we're not expecting you to do it any day in all reality, we do have to consider the humans and the complexity and how we want to implement model-based definition. So starting our approach with MOOG, we took MBD and we broke it down into 5 parts or 5 components. The first part was the geometry. Luckily, most organizations are already utilizing what I call MBD Lite to some degree. In the past 5, maybe 10 years, the level of precision, the level of detail included in geometry has increased exponentially. No longer are we omitting the fillets, the chamfers. We're still seeing some features that are missing. Oh, no, we don't need a threaded hole feature. The machinist just needs the call out on a drawing. They know how to adjust for that or program that in their operations. So focusing on the geometry, full definition or as complete as possible. So looking at practices, there were a few things we needed to optimize or bring up to speed to utilize the NX tool suite to its full capability. So that was first. And the geometry, wanting to be trusted in the future, is going to be the mathematical representation of the shape or the component that we want to build. The second part is going to be the annotations. In NX, that is referred to as PMI, or product and manufacturing information. So your datum feature symbols, your dimensioning with tolerancing, your feature control frames, surface finish symbols, notes of any type, numbered notes in a bank, or notes that are specifying a surface call out, or another finishing process. Those are all going to fall under the category of annotations, agnostically speaking, or PMI inside of NX. We also want to be able to exhibit a visual response. So we want to author the PMI asemantically, so it can be machine consumed whenever possible with the tool suite. And we also want to have that visual response, so semantically it's associated to the feature or features that it's attached to where the requirement applies. Third is going to be attributes, kind of like geometry. Most organizations are really upping how they utilize attributes or metadata in their designs. So we're not talking about just the common attributes from a PLM or a Team Center standpoint, like the part number, the part description, but actually assigning material value. Attributes is going to extend to the parametric definition of your features as well. So threaded holes. We have attributes for days related to the threaded holes that can be consumed downstream. Threaded holes are currently not modeled at the pitch diameter. You wouldn't expect them to be, but the pitch diameter, the parametric value, the metadata, the attribute, that's what's consumed in a tolerance analysis from a GD&T stack standpoint. So if it's there as data, it can be consumed, reused, transferred downstream in all of our use cases. On to the fourth part of model-based definition, as we broke it down for this foundation, is going to be the presentation states. So from a drawing standpoint, we have multiple sheets, we have different orthographic views, we have detail views, we have section views. Great for communicating 2D product definition. We're not going to utilize that method. It's time to pivot with model-based definition. So we have the opportunity to present our product definition in a more functional manner moving forward with model-based definition. The camera view, the saved view, can load as an axonometric view, and it's going to have annotations in different planes relative to the geometry or to the viewer promoting consumption or use. We're going to be able to organize annotations, product requirements functionally rather than having them split out over different views, sometimes even different sheets. Does anybody recall an older drawing where there was a hole diameter and a hole depth, but maybe the counterbore definition and the counterbore depth was on a different sheet or a different view for whatever reason? That's just the way it was laid out. We want to collect and organize all that functionally moving forward. With presentation states, attributes, annotations, and geometries, we took the opportunity to generate a new MBD template for both a part and an assembly template for future use on a future pilot. We did that in accordance with the current standards that are out there, the shalls, the shoulds that made sense, the mays that we're going to provide value, along with feedback we've collected over the years implementing model-based definition with other organizations. So not just a shall or an absolute MVP, but best practices that are going to promote the reuse inside of MOOG's organization and at the supply base. So with that and developing the guidelines in addition to support the templates that we created, we had our initial foundation to begin to re-author or remaster a pilot design. Now, the fifth part of model-based definition is not included in the pilot that we ran, but it's worth mentioning. When it comes to assemblies, we've got the CAD BOM. It's the digital representation of the parts list of all the as-modeled components in your assembly. It's there. There are nuances and ways we can utilize that data that no longer restrict us to the traditional presentation, but a little bit outside of the scope yet. We'll be addressing that in an upcoming pilot. Matt did mention the standards in play. Just out of curiosity, how many folks out there think we're in the 0 to 10 standards range when it comes to when it applies to model-based definition and model-based enterprises, as far as incorporating requirements that we need to consider? So 0 to 10, raise your hand. How many think that's how many standards we're needing to consider and include in our definition and guidelines? Okay, how about 10 to 20? All right, 20 to 30. It's okay. You don't have to vote. 30 to 40. All right, we're getting closer. So not that this is all encompassing, but we're currently considering and working with over 50 standards, unique documents, spread across 10 standard development organizations, just with model-based definition and model-based enterprises. And that number continues to grow almost monthly. Okay. By the way, as a side note, if there's any terms that you hear today, any abbreviations, or you've heard terms and abbreviations in other MBD and MBE presentations this week that you're not familiar with, or in general when it comes to model-based, feel free to check out our model-based enterprise dictionary. It's completely free. We have citation references on there, so you know what standard or what document that term and definition explanation is coming from. I'll leave that up there for just a second if you want to take a picture. All right. So once we established the practices or how we were going to decompose model-based definition, we started looking at practices in addition to geometry. One thing that is absolutely critical to maximize your return on model-based definition is to utilize modern geometric dimensioning and tolerancing. So we had the opportunity with the MOOG team to bring or modernize their practices to current practices. Also, a common practice with many organizations. When I learned GD&T for the first time out of college, I was learning to the 1982 standard, and my organization that I was employed with at the time didn't update to the 1994 standard until the early 2000s. And we're currently on the 2018 revision of Y14.5. So there's been a lot of improvements. GD&T is the language of our allowable variance, so you really want to utilize the modern geometric dimensioning and tolerancing. It is not perfect. There are gray areas and there's some ambiguity still, but it's better than the older version. So that was another opportunity that we had to improve and upscale the workforce, and the team was actually able to roll that out across the entire organization, which was huge, no small undertaking. So that, along with the templates and the guidelines, which they're going to continue to add to and refine as they learn from the pilots and implement model-based definitions specific to their organization. Once we were done with all that, we needed to identify what disciplines we were going to focus on for our first couple of pilots. So design, manufacturing, quality, and then the supply chain are the places that we wanted to focus. Under those disciplines, we had different capabilities we were going to be able to test with model-based definition. So under design, the obvious culprits being just the initial definition of MBD. Matt mentioned before they made the decision to go with model-based definition, they were getting feedback from design reviewers and other stakeholders. Just having access to the model, visualizing in 3D was huge. So you see down the list, bill of characteristics has come up a couple times this week at Realize Live, the parts list, data translation to derivatives, and then our verification and validation steps. You can decompose some of those verification steps even further. And we had capabilities that we also wanted to test in manufacturing, quality, and suppliers, but that's a lot to bite off the first time. So with this initial part pilot, also considering cross-silo capabilities, we decided to limit our scope and focus on just the capabilities we have highlighted in green. We're still going to have a complete author, manufacture, and inspect, and they opted to both inspect, manufacture, and inspect internally and externally, so we needed to include some capabilities related to the supplier that they chose to partner with for this initial test pilot. Now, with the new method or the relearning of how to author design data when we transition to model-based definition, the other thing that we want to consider is the different groups or the different cohorts that are going to be consuming our data. We're going to have more detailed definition. We're going to have different formats that it can be consumed in. You no longer need a CAD license necessarily to look at model-based definition, understand the requirements, and reuse it. But our different cohorts all have different requirements. Our authors, whether they're design engineers, manufacturing engineers, creating tooling, quality engineers, designing check fixtures, they're going to have different requirements compared to our practitioners. These are going to be folks that are actively consuming the model-based definition but not creating it. So your CNC programmers, your CMM programmers, again, different from our third cohort, the consumers, our machinists, our inspectors. We had 2D drawings previously. We need to account for what kind of data needs to be communicated to them moving forward, either in its native format, derivative viewable, or derivative attribute data, all being extracted from the model-based definition. And then finally, we have our conversers we still need to be concerned with. Management, procurement, could be sales, sustainment services. They're all going to have different needs, and these are all considerations in this new method of authoring data definition with model-based practices. So once we established that, we started to talk about the single source of truth and the different authorities. So everyone has heard either SSOT or single source of truth for a while now. It's almost synonymous with the digital thread. But as I heard in a presentation yesterday, single source of truth does not mean one model to rule them all. It's a common analogy, right? You can have a single source of truth, but you can have different authorities as your derivative data. So your single source of truth is probably going to be your design authority, but you could have a derivative data set from that single source of truth as your manufacturing authority, and then a different authority for quality, which Rudy's going to talk about in just a few minutes. We're not changing the definition from that single source of truth, that NX file with our geometry, our annotations, our attributes, our presentation states, but with the other authorities, we may be manipulating it into further derivatives, wave linking, staged modeling. We may have a QIF derivative with bill of characteristics. We can add additional requirements from a manufacturing standpoint, from an inspection standpoint. And then all of the data that's defined in those individual authorities can push information out and return as well to collect without altering the definition. So the theme is use and reuse, but the emphasis has to be on both human consumption and digital consumption. We tend to focus on just the digital aspect and the digital reuse, the machine consumption. The human factor is critical. Until the AI really does advance and lets us all sit from home in our robes, COVID style, we're going to need that kind of communication method moving forward. So we really do need to be able to trust digital moving forward. So the plan with MOOG, after we complete this initial pilot and have the feedback from manufacturing and inspection that Rudy's going to dive into, is to take the learning, update the MBD guidelines, look at what kind of training is needed for additional cohorts or additional personas in those different cohort categories, iterate, and continue to spread the digital thread throughout not only the business unit that we started with, but the additional business units that are showing interest at this time. With that, I'm going to turn it over to Rudy.
Thanks, Dan. All right, so we're going to be targeting on how MOOG is using PMI to really provide return on investment, right? At the end of the day, that's what the higher-ups are looking for. They're looking for, well, what are we gaining from this new process or new investment? So a couple of basic areas where you can, really get some value is in the quality processes, right? There's a lot of other areas, but we're going to be focusing really on quality for now. And we're going to be talking about reusing PMI data for generating automated inspection plans. That's one option. Dan talked about making CMM program more efficient, as well as Matt. And one key one that I think we miss is just improvement in internal and external communication. That's a huge one. I'll talk about that a little bit more. All right. So model-based definition, we spent a lot of time generating this MBD definition, right? We all, from the ones of us that generated drawings a long time ago, we all go back to how much effort it takes to get to model-based, right? Well, typically what happens after you've generated this model-based definition with PMI, you more than likely will generate some kind of lightweight viewable. This could be a 3D PDF, a 3D HTML, 2D drawings, right? That's still very common. And then focusing on quality processes, what you get to is that data is then translated into some kind of inspection plan, CMM inspection programming, and supplier inspection plans as well. That's all great, right? But one of the issues that we run into is that for each of one of these steps, we have a human involved. Not that humans are bad, right? It's just that they could be doing something else, right? This work is just grunt work that we could potentially eliminate. So really the focus would be to focus on just sourcing that data directly from CAD, right? From the source, from MBD. All that effort that was placed into generating that MBD is really used now, right? In essence, avoiding or eliminating the human factor of having to transcribe, because what happens with transcription? That's errors. That's automatic errors. And if it's not errors, it's a big team of checkers making sure that the data is right. So here's a very simple approach at really sourcing that data directly from the model-based definition. All right, so how does MOOG use that or source this data? Well, they're using our software called MBD. So this software actually sources all this data directly from NX. And one big step of this is characterization, also commonly known as ballooning. And by doing that, you're adding a character to each one of those PMI elements that's been defined in the MBD. That's very important for communication, and I'll talk a little bit about that in the next couple of slides. But more importantly is that this is all automated. What happened here, being able to grab that data directly from MBD was automated. There's nothing to do. Nobody had to manually put these balloons in there. So as soon as the software gets this data from the source or from the MBD, what gets generated is this automated build characteristics. And this was mentioned by Dan and Matt. So this table, or this ability to put all this data in a tabular format, really makes it very easy to transpose that data into what we were talking about, automating inspection plans and generating other types of formats. Another reason why it's important is it allows you to look at the data, right? You can find data. Which are the critical items? Which items are really tight tolerances? Just as Excel, you can find these items directly in the software and try to figure out what can you do, which Which items do I need to inspect with the CMN? Which items need to go outsourced? There's so many things you can do with this tabular format. So that's why it's critical. Another thing that's very important is that, or has been used, using the build characteristics, is using for design reviews, right? So when you're just before you're ready to release the model, you can go step by step. What are all the critical items that I need to confirm? And you can just check mark and say, yes, this looks good. And by the end of the day, you've confirmed that all the requirements are ready to go up to manufacturing. And finally, like I was want to mention, is a better way to communicate. So very commonly, or in the past, we would say, well, you're talking to a supplier or somebody in the manufacturing department. Yeah, I'm talking about this hole that's right next to the flange that looks like a space cookie. Right? But now you eliminate that, right? Now you're talking about characters, right? So you can really say, we're talking about element number 4 or item number 10. You're really just looking at numbers, and those numbers are the same across the workflow. So once again, this bill of characteristics, this ability to source the data directly from CAD or from the model-based definition allows you to automate inspection plans generation. So very commonly, you can go to an AS 9102 form or a custom form. It really comes up to you. But that tabular format allows you to do many things when it comes to automating inspection plans. Okay. So the next step that MOOG's going for and that they're very interested in is using that CAD directly into CMM programming. So by generating a QIF file, which is a Quality Information Framework file, they can grab the CAD model and pretty much push it into the CMM software. And I'm just not talking about purely geometry. I'm talking about requirements, character numbers, and features. So those two last ones are things that a CMM programmer would have to generate manually or with a semi-automated form. But it's really making this process more efficient because they're just sourcing the data directly. And then from there, you can take it over to actually running the program. And finally, the next step that you can take is sourcing that data as result data and pushing it back into the original CAD. Effectively, you get a really clean way of comparing as designed data to as built data, right? And once again, the important part is that that definition and those characters are maintained across the whole workflow. So element number 5 stays the same at the CMM level and at the result level, all kind of closing that loop. Okay, so talking a little bit more of internal and external communication. A very common situation, you have a part and you source it to many suppliers, right? We all dealt with this. And each one of these suppliers will spend the time to characterize that part. There's no real requirements. They'll characterize, one will characterize certain ways, the other one will characterize different ways. So what happens when you get this result data and you have a problem and you have to figure out where is this problem happening, or you have to corroborate the data between suppliers because you want to know what's really happening. Well, I have a 4-element part shown here. That would be easy to figure out what the differences are between suppliers. But we're used to 1,000 or very complex models with a lot of characteristics. So doing this effort of trying to combine to see what the differences are between suppliers, this could take weeks. And actually, I have customers that mention this as a critical part, where they spend weeks just to figure out why certain supplier A is having differences between supplier B, et cetera. So this actually could be eliminated or completely made a lot easier, more efficient. If the OEM, or in this case MOOG, would characterize from the beginning, they could send those requirements or that standard format to supplier A and supplier B. So at that point, everyone is looking at the same characters. They're looking at the same information. They're delivering result data to the same characteristic, right? Making it very easy for you to understand what's happening between the two suppliers. All right. So that was a very quick run through about the benefits of reusing PMI. We talked about automated inspection plans, how you can generate that directly from software like our software Capvidia, making CMM inspection more efficient by using QIF files, and just in general improving external and internal communication. One thing to note, and I think a lot of the effort here is, or a lot of the effort in the past year has been on digitizing data. And by that I mean actually grabbing legacy data, putting in a PDF format and uploading to a network or uploading to a cloud, right? That's great, now it's accessible everywhere. But that data is not machine readable. What can you do with that data? What's the benefit there? It kind of has to stop there. And why is that? Because we need a human to interpret the data. So the key thing is to focus on how you can make a digital process. You know, all that effort that the designer spent on defining a model base, have it actually work for you downstream. So that's really the important part, right? It's just to make sure that you're making something that could help you out in the future. So now I'm going to pass it along to Matt. That's all we have on the quality side.
All right. Thank you. What a great overview from Dan and Rudy here. As you can see, that's some of the core technologies and concepts that we are trying to deploy in MOOG. And let's get to the heart of it here. You know, some of the lessons learned. You know, what have we learned so far by doing this? By doing this pilot project, these are some of the things we're learning. We're continuing to learn. I expect us to learn much, much more. So, PMI, good modeling practice, that is the foundation of your MBD. But it is also the easy part. Defining your model, putting the PMI on your model is pretty easy. You could take someone who's familiar with NX drafting, you can teach them how to do this PMI in less than an hour, and they'll be able to go run off with it. What's harder is going to be to get them up to speed on GD&T, honestly. But as far as defining the models, that's the easy part. The hard part is the downstream application, but that's where the real savings lies. You know, hopefully you've seen capabilities of the QIF file. Maybe you've been in some other presentations on it. It's easy to see how much you can do with that. You gotta have trust in your single source 3D models. Models and downstream derivatives, they must be validated. You know, you gotta have some way to validate your models so that people trust what they're getting. They have to trust that the step file, the JT, the QIF, 3D PDF, whatever your derivatives are, they have to trust that it's the same as your nx.prt file. They all need to be validated and trusted. Employ standard practices in accordance with ASME Y14.1 and 14.41 and 14.Y7. An example that I have here, just because it's one that comes up, is model to nominal. You know, what that means is when you're modeling, you kind of shoot for the middle of the tolerance, which is what your manufacturing groups are probably doing anyway. They're probably taking the dimensions and they're figuring out what the nominal is. So they love this. This is something they've been asking us for years. Dan convinced us that we should be doing this, and it's been a big hit. GD&T, that is the language of MBD. Dan mentioned this. You know, in a model-based world, the success is going to rely on acute understanding of the GD&T. And this, from designers all the way down to your builders and inspectors, you've got to have good understanding of GD&T. You need to cultivate local experts. You know, find your key users. There's some people who really love GD&T. Find those people. You know, make them your experts. You're going to need some new roles. New roles are going to be needed. There's a lot of new concepts and new things that are coming up, so you're going to need new roles. But established roles aren't necessarily going away. They are going to change. What I'm talking about here is mainly drafters. Drafters are very scared that in a model-based world, they're not needed anymore. That could not be further from the truth, because they're the ones who understand all this stuff already. They already have a good understanding of this. They're just taking it and applying it to the model instead of the drawing. So the roles are going to change a little bit, but you know, don't be scared that you're going to lose your job because there's no drawings. Education, training, upskilling, very important. Very important. We've got a website that we've been working on. Karen back there has done a lot of great work on that. Just to how do you get this knowledge out there? You got to come up with a good communication plan, education plan. You got to give people the opportunities for success. Don't just throw this stuff at them. You got to give them the opportunities for, making this a winner. MBD, it's not just design. When I first came into this, MBD, we're thinking, oh, this is just from the design world. No. If you want to properly implement this stuff, it's going to encompass the entire organization that you're in. It's going to affect nearly every user and almost all your business processes if you do it right, because MBD is a process transformation. It's changing, it's going to change the processes. If you do it right, if you want to get the value out of it. Now, of course, you could just start putting dimensions on your models, use the processes you already have now, but you're not getting the true value out of it. What you really want to do, spend time, re-engineer your processes, and apply the MBD where it makes sense. And it will be obvious where you should apply that. So, user adoption. That's what I feel is going to be the biggest challenge. The thought of life without drawings, it's a little scary to some people. But you have to push these people out of their comfort zones, and they'll get used to it. They'll start finding things that they like. And how I do this, you win people over first by showing, then by including. You want to include your key users in your pilot projects. You want to give them a sense of ownership, let them have input, let them know that this is for them. This is not something we're trying to dictate down. This is to make the business better. Seek out your skeptics. You're going to have some skeptics. Seek those people out, because you might just feel like they're complaining all the time, but many times these complaints are legitimate, and you need to address them early on, not later on. And the culture change does not have to be a culture shock. You can do culture change, you just got to include the right people in this change process. So the final thing here, know that there are still lots of limitations with the tools, with the industry standards. Things are constantly being developed. Dan said there's over 50 standards that are being worked on. So constantly being updated, revised. It's difficult to stay on top of. That's just why we have Dan here and Rudy here to help us out with that. So with that, thank you all for attending. And if you have any questions, now's the time.
All right, thanks everyone.
Yep.
Thank you.
Thank you all very much.